This is the Math Map Book Club where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
So welcome to the Math Map Book Club. Today is February 4th, and Kirsty informs me that it's also our 9th year anniversary for her and I meeting at least once a week in order to develop this curriculum. So Kirsty, thank you for your perseverance for all that time, and welcome to everybody else who's on to talk to us about math and ask questions about helping their children use the Math Map and the Classical Conversations curriculum. So Kirsty, what are we going to celebrate about math today?
Well, we are looking at lesson 22, populations, today, which is all about really celebrating us. And so happy anniversary to you. It does not feel like 9 years. So when I stop and think that it feels like we've haven't been doing this that long, 9 years seems like a long time. But it has been a time full of joy in how God has provided. So I'm excited to look forward to the next 9 years, I hope. So as we do every week, we start by talking about strategies for flashcards. And this week, this used to say fast facts, and I added a word and reordered it so it would say familiar facts fast, because we don't want to aggravate our students or discourage our students by asking them to be fast at something that is not yet familiar. If it's not familiar, you can't be fast at it. But the things that are familiar, the things that you feel like we're getting close to mastering, that's a great time to go through and start being a little bit faster or going through quickly so that you're improving the speed of recall and also quickly going through and saying which ones really are familiar and which ones do we maybe need to put a little bit more work into. So I just thought I would mention that today, that this is not a strategy for the first time you go through your flashcards, but it really is a good strategy for when things are becoming familiar to you, that then you can start to add a little bit more speed. And then always at the beginning of the week, we like to talk about our covers. So as we look at this piece of art and this cover here, I know that you can't really see it on the screen, but if you happen to have yours handy and you look at it, this piece of art is actually a type of mnemonic device in some ways. And so if anybody happens to have it handy, what is the detail on this piece of art that it might be helping to remember? Even if you just look at the picture here on the screen, what does it look like to you? What are some things that are familiar to you that you might remember from this?
The picture's small. I'm not quite sure what you're asking, Kirsty. Meaning like there's a tree and there's a pyramid. Those are mnemonics? Or
So
what do you
they
think?
They are. So if you look, so think, if you look at that and you think, okay, there's it does look like a pyramid, or it could also be called a tower on one side. And then we have a rainbow off in the distance, and then we have some people there. And then we have this family tree in the middle. These are some Bible stories that this is communicating. And if we were to look at the names on that tree is actually helping us to see how after the flood that God populated the earth. So there's this piece of art can actually help us to remember some of our stories from the Bible. So that's not true about all of our pieces of art, but this one in particular does actually have some specific information there that would be useful if we're trying to recall some details about those stories. This is a great piece of art also to think about comparing different sections of the art piece. So last week we talked about comparing different pieces of art, but even within the art, right? What are some things, how might this be this one, right, I'm going to compare the arrangement, or I'm going to bring the arrangement in here because we can see here that this art is arranged to give us some different vignettes, and we could compare those vignettes, right? How is the tower like the tree? Right? What do you remember, right? If we were comparing the tower to the rainbow, right? The rainbow we could maybe see is an example of man's faithfulness, that Noah was obedient. And because Noah was obedient, he was able to see the rainbow, which was a symbol of God's faithfulness. Yet on the other side, we see that tower is an example of man's lack of faith, right? And his desire to be like God. So we can compare, pulling from our memoria, using the arrangement, we can kind of compare different sections of the piece of art. We could also just look at them specifically and say, okay, well, what are some of the shapes that you see in different sections of the piece of art? So it doesn't have to necessarily pull from your memoria. If you have students who are not quite ready to to pull those pieces together, but you could certainly talk about, where do you see curves? Where do you see straight lines, right? Are they in different places? Are those things that are being drawn different? Again, with our students who are older and a little bit more familiar with art, especially those who have done some work, perhaps using Marvelous to Behold, right? Just talking about the styles from different eras of art, right? So on here, it talks about that this is, I think, 1756 or thereabouts is actually on the piece of art. And so what do we know about that period of time? What do we know about other art in that time, right? How does this maybe look differently than if it was created today, or if it had been created 200 years previously? What might you expect? So those are some ways we can talk about styles and elocution. And then, not necessarily related to this piece of art, but I was just thinking about how the binding of a book can change our perception of it. And since these are Bible stories, I was thinking about the fact that when we think about our Bibles, they're usually bound, right, in leather or something that looks like leather. Right? And what does that communicate to us? Would you feel differently, right? You also can get Bibles that are 3-hole punched, right? So if people want to do journaling, you can get them so they're 3-hole punched and in a binder, right? How do you feel about each of those? How does it make you feel about those pieces of art, right? And again, trying to get to that idea of the delivery and how important that is.
That makes me just think about how there's a different respect you have, and a different sense of pragmatism and purpose that you have. And for it made me realize that people who do everything online and think that's adequate, they never get to feel that weight of a really permanent book, or the lightness of something that's meant to be thrown away. Like that adds to our understanding of how God made things for us.
Yeah, even the books, Lee, that you chose, right? That the delivery of the booklets themselves communicates a purpose. They're not stitched, they're not bound, right? That the idea was that they're stapled so that they can be separated and pulled apart. That was intentional, right? It's not one big heavy book that weighs you down. It's these 30 individual booklets that are intended to be used, right? Over and over again. So I think it's just great I like what you said, Lee, about pulling our students back to that real world experience, right? And how does the delivery communicate things to us?
So one thing about like my preference would have been that these were hardbound so that they had a weight to them. But one of the reasons we needed to write a curriculum is people were not paying attention to the pedagogy of the average math student who struggles. And so we made that decision to make it light for their benefit versus something really heavy for that student who's already very good at it.
And then, talking about our delivery and the intentionality, I think that's a great point, Lee, is that it was an intentional choice. It wasn't it was an intentional choice. And I remember that early on that you wanted this to be something that felt accessible to students and to families. And you recognized that families were often doing math on the go. And so dragging around a thick book that's not always conducive to success. So I appreciate that intentionality. And likewise, the intentionality of including the math map in every single booklet, because we want students and families to know where you are on your math journey and to see where that is. In your traditional textbook, we all know that at the beginning there's a table of contents and at the back there's an index, and we can use those tools to find things within the book. But the reality is that with the table of contents, a lot of people don't ever look at it. They just flip to page 1 of the work and they start going from page 1 through. And so the math map is intentionally different, and Lee intentionally keeps this at the forefront of every book to remind us how we can use the math map to know where we are and to be encouraged that we're going to see these ideas again and again each year. That brings us to our lesson pages. And so on day 1, each week, we like to talk about what are some of those strategies we can use for those lesson pages. And we're going through the same list we went through in the fall. We're going through it again and looking at it perhaps in a little bit different way. And the strategy this week is to scale the number of pages completed. And the simple way to look at that is to say, we'll just do fewer pages. And that certainly is a strategy that families can use, is to do 2 pages a day instead of 4. But I wanted to suggest to this week that we could also change what our expectation is for each page. So instead of saying we're only going to do pages 1 through 8, maybe we strategize and we say, okay, I'm going to give you a different assignment for each set of pages. So maybe pages 1 through 4 is copy work. Use your solutions. And I just want you to read and copy. So there's no figuring out involved. They just get to copy and they get the basic grammar for that week. Perhaps the next 4 pages, you tell them all they have to do is complete the things that are familiar to them. Find the things that you can do and just do those, and the things that are really unfamiliar and overwhelming, just leave them. Maybe the next set of pages you say, okay, today I want you to look at the patterns or the charts for those things that were less familiar. Or maybe you revisit pages 5 through 8 and you take 2 days to do those 2 pages. So you do familiar on one day, and then you dive a little bit deeper into the unfamiliar the next day. And then maybe at the end of the week, you say, okay, see what you can finish of what's left. Alternatively, you could always say the first 2 days, we're just going to start with the familiar, and then we're going to come back and attack the unfamiliar. And so that our goal isn't necessarily that we have to complete all 16 pages, but we're expecting our students to be diligent for some given period of time. For most of our challenge students, that might be an hour. We say, you need to give me an hour where you're not distracted and you're not playing games and you're not kicking your sister under the table, right? You're going to give me an hour where you're going to do the work that I've put before you. And if you only get 1 page done, that's okay, right? Because we want to reward them for being diligent. Within CC, we have words that we look at, and diligence was one of the words we've looked at recently, that it describes the attitude towards the work. And so when you're diligent, you are almost loving the work, right? It's this idea that you respect the work, that you're putting in your effort because you recognize the worthiness of the work. And so this strategy is a way that we can help our students to be diligent rather than just trying to check the box. Any questions on strategies for lesson pages or anything anybody would like to share? I could be wrong, but Lee, I think this is one of the most restful lessons that you have put in the math map. And there are some big ideas in here, but I think that
I
the
have,
lesson is very restful. Nicole.
well, I just had a thought, as far as making some adjustments to make sure that the kids kind of are making progress. Um, I combined at one point during a very, my mom passed away a couple weeks ago, and so it's been very um, abnormal to say the least. So I noticed that, if we're not able to check off something in a day, then the next day we feel like we have two of those. And so one of the things that I think helped during this season was we have like there's a certain number of pages that we've become accustomed to being able to get done, even though we were, I was saying, I need you to do 15 minutes of flashcards and then 35 to 40 minutes, and it doesn't matter how many pages you get done, right? But generally speaking, after you do that for a while, you get this idea of how many pages you might get done in about 30 to 40 minutes. So when my daughter had more time on one day than she had on another day, she could say, I did 2 days worth of work, not so much because she spent 2 hours, but because she did the same number of pages, maybe in less time, that she had been regularly doing in 30 minutes. And then she did that again. So she was able to get 2 days worth of work done in her mind, even though she didn't have to spend 2 hours worth of time doing it. So I just thought that was really helpful because then I don't feel like I'm really slacking, but we could skip a day or two here or there. And we've had this rhythm for long enough where when we do have to be arrhythmic, it's okay. We kind of know what we need to get done in order to stay with our community. So I thought that was helpful.
Well, thanks, Nicole. I'm sorry. Sorry your family's going through that loss.
No.
Thank you.
We'll be praying for you.
It's also what you shared is a good sign of taking ownership because one day she's going to be an employee or a student off on her own or just doing something for the Lord. And all of us need to know how to gauge time and not be ruled by the tyranny of the urgent. So it's a great lesson that you just shared. Thank you.
Mhm. Mhm.
So lesson 22, as I was saying, I think it's a very restful lesson. So if you're a family that's looking for an opportunity to catch your breath, I think this is your best week to do that. Um, it's full of, I think, I like all the color. I like all the images. I think that that's one of the things that makes it feel really accessible. But are there any questions from page 1? I think here you're going to see that there's a definite rhythm with each day being similar, right? That we're going to be looking at arrangements every single day. The bottoms are going to change a little bit, but that's maybe one of the things that makes this feel more um, familiar is that we're not cramming in so many ideas, but we're really resting in them as we go through. So on day 2, we like to recommend that you take a look at the I squared invention page. And this is the page where we practice the 5 common topics of invention. Again, our skill is to practice this week authority and testimony, not the math. And I thought that when we think about authority and testimony, right, what the questions are we might want to ask our students is, how do we know that something is true? But this does require a little bit more mathematical understanding, right? So if we're asking our students to pull from their memoria about laws and definitions and properties, or maybe that they remember a math authority that they've read about, such as Euclid or Euler, right? Those are things that are going to be pulling from our memoria. But we could also say, look at this and say, okay, well, right, how do we know that those are multiples of 3, right? Or how might we know that 30% of the people said dog? Right. Well, we can see that because the chart becomes sort of an authority to us, right? We can see how these arrangements are. So it doesn't always have to be pulling from our memoria. It can be just looking at this and saying, how do you know something about this, right? It's because our charts are telling us. And then the other question you might say is, well, what could somebody tell us about this? So we have that idea of authority, right? The laws, the definitions, the properties, that's that sense of authority. But then we can say, well, how can somebody tell us about us? What's the testimony? And that might be a parent's experience. Okay. So you might look at these all of these different arrangements of data here, and you might go, oh, well, that's like when we were shopping for a new refrigerator, right? And there was these charts that we had to look at that gave us all of this information. So a parent might pull in their experience. We might look at other exercises, or we might look at examples. Those are some testimonies that we might get. All under that authority / testimony banner, but those are some ways that I like to think about how to determine what those are. Anybody have any questions about authority and testimony and practicing that with our students? And I just want to point out that when we talk about this each week, we don't mean that if you're watching us this week that you have to talk about authority and testimony with the lesson 22 iPage, right? That we're just going through these, and these are things that you can use on any of our iPages, on any of the lesson pages. So in your home, if you have younger students, you might just be talking about definition. That might be all you want to talk about, is picking out a couple of words you want to define each week. And that's enough. So I don't want these where we're talking about pulling from memoria and bringing in experiences. This may be something that we do more with our older students than with our younger students. Although we can certainly be working towards this with our younger students. But I just wanted to point that out, that we're giving general strategies here, not weekly specific strategies as we look at these.
This page always makes me think about science fair because we just finished science fair in Challenge A. And so just helping students see all the different ways you can display your data, because I think a lot of them are just like the pie chart and the line graph, maybe the bar graph. I mean, they're the most common, but these other ones are so full of color too. So just showing them that there are different ways they can display their data depending on what their project was.
That's great. And so here's our day 2. Notice again, we're looking at using arrangement in each of these days. So we've got different ways that we can use two-way tables, for example, building from our younger students up here through our monomial students. The charts this week have a long list of cue words that you might use for converting from words to symbols to write an equation, and that's what we're practicing at the bottom. So we've had good feedback that people like that list.
I feel like oh, sorry. I feel like on monomials we should take a field trip to a yogurt shop and just do that in real time and see how many flavors, see how many combinations. That might get expensive. Maybe we should do that at home.
That sounds like fun, though. All right, on day 3, we suggest that you take a look at our I-cubed memoria and arrangement page. This page, along with the charts, I think if you look at these, this is a nice simplification or a nice survey of the charts for this week, because what we really tried to do was point out how we use those 15 skills of learning in mathematics all in one week. So we talk about our memoria, our invention and the common topics, arrangement, elocution, and delivery. And when we think of memoria, we know that we're also talking about those core habits. And so this is a great lesson for parents, probably more than students, but for parents and tutors to increase their familiarity with those 15 skills of learning and how they might help us in mathematics. Which reminds us that this is a classical math curriculum. We're not trying to teach a set of algorithms that your students just blindly follow, but that we're trying to teach them how to ask good questions, how to practice these core habits in order to learn the mathematics over time. So it is a totally different approach, and it's going to take a couple of years for people to really get comfortable with that. But this is a great lesson as a resource for where those 15 skills fit in all in one place. When we think about those core habits of memoria, this week we can talk about memorization. And all of my memorization tricks really were honed in foundations. Right? The number of years that I sat in foundations, and what did I hear? You have to repeat it 7 times. Say it, listen to it, write it, incorporate movement. My son is in fire academy and they do an EMT portion, and all in one chapter. It was like all of the human body in one chapter. And it was amazing to me how much he remembered of those systems from when we did this in foundations, and then again in challenge A, where we drew, right? We copied and we drew those body parts. Those are those memorization skills that we can bring in and apply here to mathematics. Some ways we can scaffold that are by looking at the highlights. So if we look at this page here, right, we could say these are the highlights of this page. I want to memorize my 5 canons. Maybe I start there. And then as I increase my depth, I come in and I add my common topics. And we don't have them listed here, the core habits, right? But that might be the next thing that I add in. So I'm continually adding in to increase the depth of knowledge that my students have. I could also scaffold by beginning with prompts, but then taking those prompts away. We do that, I think about, as we think about that with the Memory Master. And I remember when we would have our students, right, they would start off with their Memory Master and they might need to be prompted. By the time they got to me as a director, right, I didn't prompt them, right? I would just say, give me your timeline, or tell me, right, what happened in the 1980s. I would give them the question, and that was the prompt that they got. I didn't have to like sing the song or anything else, because we started with that and then we lessened it as we went on so that they were sort of weaned off. And so we can do that with our students in math too, right? Prompt them a little bit and then expect them to do more and more. And then another way we can scaffold is having our students to sketch an arrangement, right? So when we think about this, take a look at this page and now turn it over and draw out, what do you remember from this page, right? So that they're drawing a sketch. They're not trying to fill in all the information, but they can do a general sketch of what was here. So those are some ways that we can scaffold memorizing for our students. And then looking at our page 3 here. Again, looking at some tables, reading information from tables, practicing our bar graphs and our pie charts. We're going to continue to see this practiced. And then at the bottom, looking at probability. And you can see where we move, right, from simple, we're going to get increasingly more challenging as we build that understanding of probability. For the record, probability is something that is simple when we're thinking about what's the likelihood of heads or tails, but very quickly, probability is not something that we intuit. I read that once and I found that to be really encouraging, that probability is not intuitively obvious, that this is somewhere where we really do need to attend very closely, right, to our probabilities, because it's not something that is inhumanly intuitively obvious. Any questions from page 3? I know I'm going a little quickly. We have some really good questions that were sent in, so I want to make sure that we have time for those. And day 4, looking at ways we can use our careful calculations page. And as I was looking specifically this week, this is a really great week to take those careful calculations and to model those exercises in the real world. So as we look here and we're putting things in order from least to greatest, well, let's go and find some things and have our students order them, right? So order your books, for example, by height, right? From the smallest to the greatest to the least. Right? You could take pencils, right, that have all been sharpened to different lengths and order your pencils from shortest to longest. We could order weight, whether you actually measure the weight or you have your students judge the weight to put things in order. You could order areas. You could order ages, right? So giving your students the opportunity to do some ordering that matches this idea of what they're doing here in the careful calculations page. Similarly, if we have some measures that we've ordered, you could calculate their averages. So this is a lesson that is very practical. It's called populations because it's about our human space. So this is a great lesson to pull some of those things into the real world. Lee, did you have something you wanted to add?
Yeah, I was gonna, another thing, Lily, my granddaughter Lily gave me this idea. She's very athletic, and besides going to a lot of her own events, she's drugged to her brother's events. So on her own, she has started taking the statistics of the 5-year-old and the 9-year-old, just so she has something to do. She watches their team and, writes everybody's name down and, how many pitches and hits and all that. So she's doing statistics all on her own a couple times a week.
That's great.
Yeah.
Another thing that's really, as we look here and you see that we've got these factorials that we're doing, and then combinations and permutations. Again, this is a great thing to actually act out with toys, right, or objects. So when you have, right, we used to do teddy bear parties, right? So we'd put all the stuffed animals out and we'd think, well, how many different ways could I have a party with these animals, right? How many ways could I put them in order? How many ways could I have a party that just has 3 of them? How many ways could I take a picture? And so that really helps to make the idea of the factorial and the combination and the permutation real to our students because they can actually manipulate things in order to figure out what those should be. I would suggest you work with small numbers because, as you know, with a factorial, those can get big very quickly.
I have something else practical. Every time there's a wedding photographer trying to rearrange all the family groupings for pictures, they're using this math, whether they know it or not.
That's so true. All right, and then there's page 4. We're looking at our Venn diagrams and our Euler diagrams. We've had a question. Somebody was asking when we see something that looks like this, where we just have 2 sets, is this an Euler diagram or a Venn diagram? It could be considered both because it does show all of the possibilities, as long as but usually, I'm just going to say this, usually in the math map, if you see data put in, if there's data put into it, then, and there's no empty sets, then usually that will be an Euler diagram, right? So as long as there's no empty sets, as long as there's, it'll be an Euler diagram. So that brings us to our reminder of how we can be here for you every week. You can join us at the book club, but certainly our support extends well beyond that. So take advantage of that. Next week we'll be on lesson 23, which is moving us into our 4-dimensional lessons. So that's exciting. We're skipping through the dimensions pretty quickly now. So let's take a look at some of the questions that were sent in, and then certainly we'll have time for questions that you may have brought with you. This one I want to address because Lee, what this looks like in the current digital download is a little bit different to what's here, and so I think that this is a little bit more friendly than what this parent had encountered. I couldn't find the picture of exactly what they'd encountered, but their question was that their 6-year-old, they do flashcards daily, and they got to this set, and what it had said was something like R equals 53, and then it said 58 minus R equals blank. And they felt that that was a lot to both substitute and do double-digit subtraction. And they were wanting to know what your vision was. I think showing the updated lesson helps a little bit to see that you've made that more accessible to a student. One, because we're still doing some double-digit work here, but you're demonstrating a way that students can approach substitution, first of all, by writing the number on top. So if we look at the first one, a triangle is the same as 12. So we can actually write that 12 in our triangle. And then we see we have 3 plus 12 is 15. And if I have 15 minus 12, I get 3. Last week, we talked about how Lee works really hard to put the answers on the page. And so there are some places where that's not always the case, but this is a really great case where these problems are not two isolated examples, but rather that these go together. So notice if I have 3 plus 12 equals 15, here's my 15, here's my 12, and I get my 3. So Lee is giving us an opportunity to practice this idea of substitution, but in a way that's perhaps a little bit more accessible to a student. And then we're also practicing these related facts that, for example, 3 plus 24 is 27. So 27 minus 24 is 3. So I didn't know if you had anything you wanted to add about that, Lee, in terms
Well,
of
one thing, and I'll double check in the new one, because on page 4, we probably should have had the first total row done so they could see the pattern. And we almost have it done on this one. So I'll double check that. And then the second one is where what you said is just true. You're not necessarily practicing 27 and 24 and what that means, but what are the patterns? The thing is, she's saying, I'm a little confused because as to what level she's saying this is. It looks to me like it would be from naturals. Yeah, they should be. Yeah, they should be just single digits in naturals. Yeah, I don't see where it says it's naturals. That looks like it's older to me. So I'll look into it.
Okay. Great.
Yeah, I mean, because we do have some double digit things definitely in naturals and integers, but there should be a pattern they can follow. So I'll figure out what happened.
Well, I think there is here. I think in the original document that the digital version was before you'd made some edits to it. And so Jill and Babs can attest that the original versions that people worked with were a lot less accessible than the ones that are out there now. And so Lee has continually refined them. And so where this, where on the right-hand side was in those digital versions, Lee has worked really hard, I think, to make those more accessible to families. And so it now looks like it does on the left-hand side. And hopefully that will be, will answer that question.
Yeah, I mean, they're first, second graders, they should start to mess around with numbers in their 20s. But, then again, it's that opportunity to find out as a parent, oh, you really don't know what 24 is? I thought you did. Right.
So looking at this question, there's many here that I thought were really great. And I think that this comes from probably a foundations family that is not familiar with our blue books in Challenge. So in Challenge, we've been using this idea of a blue book assessment for many years, and our tutors are well prepared to equip families and have that conversation. But if you haven't been there yet, this may be something that's new to you. And so I have answers for these, and I'll try to be quick, but then I would certainly love to hear Lee or anybody else's perspective. So first, do teachers or students choose the questions and the topics? And it depends on the age of the student. It depends on the level of the student, the maturity of the student. You could always have some of both. So as a teacher, what is your goal for your student? What do you want to assess? And then maybe let your students pick a question. What's a question that you think would be a great question for you to demonstrate what you know? Then are they decided beforehand or on the spot? So again, it's usually something you're going to choose beforehand, right? But it could be on the spot, right? Maybe you're traveling or life has gone sideways, and so you're doing your assessment on the road, right? So maybe you're coming up with some things. Here are some things I want to know if you know. And so it could be that you're doing this on the spot, especially with younger students, to make it a little less formal. But I would also argue that there's a benefit if you choose your blue book questions almost at the very beginning of your semester, right? What are the things I want to accomplish? And then you ask that question at the end to see if you did accomplish it. Again, whether they're written down or asked verbally is up to you as the parent. Right? I found as a tutor that I would usually have the blue book questions for my challenge students, and the real assessment was when we reviewed. And I would ask them the questions verbally and we would discuss it. And that's always when I knew who really could answer the question, right? Because I would see what is it that they already remember? How are they thinking? And so that verbal exchange was as important to me as the actual written work that they did the following week. And so again, that's going to be up to your family and to your child, which is going to be the best fit for you. And then, yes, right, if it's an assessment, we definitely want to have some kind of evaluation that comes out of that. And that could be that you sit down with them afterwards and you say, okay, this is what you knew. This is what we have to practice. And especially with younger students, looking at it holistically as a team, right? What could we do better instead of what do you need to do better? I think is one way that you can encourage them to work with you in the coming semester. So those were my quick answers, but I would love to hear if anybody else has some things that they'd like to chime in.
Something I just like to mention is that, excuse me, Kirsty, you did a good job on your charts for weeks 15 and 30, where there's general questions that can be asked to stimulate conversation. And then if you look at the careful calculation from week 14 or week 28, there are some calculations to practice that could show up on the blue book. So those are just a number of examples. When it comes to digits, naturals, and integers, I would say treat it like a coloring book. If you want to have the child write some math problems in there, that's fine. But the main thing is for them to feel like they're part of a family and they know where they're going in life, and that blue books are comfortable, because even in first grade, I saw them and got to write in them. Who cares what math they put in them? And then once you get on to the decimals, fractions, and integers, you might want to take a careful calculation page that as a parent, you remember they did really well on, and ask them questions from the ones they did well on, not from the ones they didn't do well on, for that grade level. Then once you get more towards reels where they're preparing for challenge, you might want to look at 15 and 30's charts and get ideas for what's coming for when they're in challenge. Because the challenge blue books pretty specific how it is administrated in the seminar, but that doesn't mean the parent can't do more with it or to prepare for it at home.
As a Challenge A director, I think too, I like having input from the parents as I'm making the blue books. And so I'll say, I've looked over, week 15, and these are a couple of the ones I like. And ask them, what do they think about those questions? Especially like I know what we've talked about in community, so I know they can answer them. And so, I'll ask the parents, hey, I know we've talked about these. I want to ask these questions. Do you have any other ones, that you'd like to see on the blue book? So I kind of like to get parent input specifically on the math portion because they have a copy of the charts. They can see, possible sample questions and just kind of ask them. I mean, obviously they can add more to it, when they get home as they're assessing their own student. But I do like having the parents' input.
I also think at the challenge level, it's really important as a tutor to have one question, and it may not be from math in the blue book, that they remember having a great discussion around. So they're pulling from their memoria for that.
I think a
Yeah,
good example of that is the conversations we have with the art. Because I know we always have good conversations with the art. They always find some of the weirdest things in the art that I have to put my cheaters on to actually see because they're so tiny. But so that's a great idea of pulling in something they enjoy. And so we always enjoy our conversations about the art. So
Yeah, for those families that are unfamiliar with the Blue Book, it it isn't anything magical. They're called Blue Books because originally the covers were blue. And that's the only reason why they're called Blue Books, but they were blank books. So the idea behind a Blue Book assessment is that it's not necessarily multiple choice. It's not true false. It's not matching, that it's supposed to be open-ended so that the student has the opportunity to demonstrate what they know. And it's important not only to look at what math concepts do they know. So we're tempted to jump right into assessing, can they add, subtract, multiply, and divide? But think about the other skills of learning that you could do, right? Is there something they memorized that you could ask them to do? Or just the general skills of our homeschooling. Can I dictate something and they can write it? Right? Or was there a math word that you worked on spelling? So it's the spelling of it that you're perhaps checking. There's a lot that we can do with that blue book being open-ended, that you as a family and you as a parent can use that to celebrate what they know, or perhaps for those students who are very confident and maybe it's an opportunity to help offer a little humility. Right. And so it becomes a piece of your character education. Do I need to build this student up and encourage them that they can do this? Or is this a student who maybe needs to recognize that there's places where they need to attend more closely? And those are questions that only a parent can answer. But that's the beauty of the Blue Book, is that you can make it the assessment that you and your student and your family need.
I think that's a misnomer that tests and assessments are for the teacher. They're for the student. And that's the big difference with a classical education versus a modern education. We're not trying to shove 40 kids in an hour through a test system that can get graded efficiently by some adults. We're trying to work with just a handful of students. And, I, as a tutor, just gave very cursory notes when I went through their blue books. I wanted them to know, to give feedback, and I wanted their parents to give feedback because I don't go home with them. And, it doesn't matter if you have the same kid for 12 years, if you're tutoring them at a school or a small private school, you're not going off to work with them. They need to know how to assess their own work. And that's what we're practicing. They need to say, yeah, I'm ashamed. I need to overcome, and the Lord needs to help me. Or they need to say, you know what, that work paid off. Or the one that's the hardest is for us type A people. This is too easy for me. Why do I not push myself more? Or where could I push myself more? Where could I go deeper? We're not trained to talk like that to ourselves through a school system. And this is a point of the Blue Book, is to be able to have those conversations.
Didn't I hear
Another,
that they're coming out with that other colleges are starting to have blue books again? Like it seems like I heard it the end of last year
It's
that
because of AI.
yeah,
They
yeah.
they don't want to they want the kids to walk into a room with nothing, be given blank paper, and say fill them up. And
Mm-hmm.
that's the way education always was until we got copy machines. Then school became efficient for the administration rather than effective for the student. And that's the battle we have. And that's the battle in the math map, in any math course, not even math map. Saxon doesn't matter what it is. People have been trained that somehow this should be easy and efficient. And we're trying to say, no, education is struggle. It's struggle. It's struggle. But boy, do those Pentecost moments hit often when you go through those struggles. And then there's so much joy. So,
Another thing that, and you might not necessarily do it on the week 15, but a way to kind of assess through the year. I know for me, the first time going through the math map, things that were hard for me in the beginning weeks, there would be a light bulb weeks down the road in a totally different booklet when more information came or more practice came. And I'd say, oh, I think I can go back and do that other page now. So if your students have those kind of aha moments, including those, going back, taking the time to pull that and including that, at least a record of it in your assessment and showing them where their aha moments are, I think that can be really effective and help them the next year through on that same book.
I mean, you do it in your Bible study all the time. You're reading the New Testament and you go, that's what that thing meant back then. Right?
well, I just had a really hard aha moment. Lee, dang it. But my question to myself now was, am I trying to make this efficient for me to administer or effective for my students? Crapola. Like that is a hard realization. Like how many years have I been trying to figure out how to make this easier for me as opposed to most effective for them? Ouch.
Yeah, I was mentored by a homeschool mom in my early years, and she's the one that told me that she was an ex-teacher who was homeschooling, and she said homeschooling had taught her that education could never be both efficient for the student or for the teacher and effective for the student. It was always going to be one or the other, and it was a constant balancing act. Because as a teacher, you don't want to give up, right? You want to be able to be effective and help. On the other hand, if you're helping too much and it's all central planned, the student is weakened. So and these are the questions I have for God when I
Ouch.
am done smelling him for 10,000 years when I meet him. Is now explain to me this paradox you put us in where our husbands have to go to work when our babies are little and that they sell Girl Scout cookies during Lent. Like, why is everything mixed up?
It's hard. And I think, I love the fact that you said the type A person, right? That for those that are type A and I want to check it off and I want to be efficient, um, that sometimes it's hard to put that aside. And maybe that there's a spiritual lesson in that because don't we all want there to be a checklist, right? If I just do this checklist, I'll get into heaven. And it doesn't work that way. And so maybe this is God reminding us, right? There's not a checklist here that it really requires, right? Sometimes, as I've been doing this for 9 years, I homeschooled while I was helping Lee with the math map. And so I'd be like, no, I really want to get this done. And my son especially would be sitting there and he would desperately want my attention. And I'd be like, no, I got to check this box off. And when I finally learned the power of saying, you're more important than this checkbox, right? That this can wait. This thing on my screen, this thing that I'm doing, this can wait. And I'm going to turn and I'm going to look at you and I'm going to give you my full attention. That was a really powerful moment. And I learned then that just a couple of minutes of that, of giving him my full attention, usually meant I got back to the thing I wanted to do or I needed to do a lot faster
Mhm.
than trying to split my attention. So sometimes in our attempt to be efficient, we actually are less efficient than if we decide to be effective, then maybe God will allow us to do all the things. So
And I mean, I just got this really cool, cute digital checklist that my kids are doing daily, and they love it and we love it. So my heart wants to defend the checklist, but I think I hear because it is helping in our homeschool, but I think
Mhm.
I hear the tension of knowing when to abandon the checklist. Right. Like the checklist is not the
Mhm.
master of me. I am the master of the checklist. And if I
yes.
need to ditch it, I need to ditch it. And if it serves me, it's a tool, just like a hammer. It's a tool that if it serves me, I can use it. And if it doesn't, and this idea that we want both efficiency and effectiveness is it's definitely true. I definitely want them both.
Nicole, I think the most successful homeschool parents have a schedule and they have a checklist because the Lord's done that, right? We have 365 days in a year. We have 4 seasons. About a third of it's dark where you can't get things done, right? And so that's his checklist. That's his form. That's his frame that he's allowed us to fit in. The continents don't move, right? Temperature differences aren't that great for the majority of the earth. He has made a wonderful form, and then we can count on the crops that grow, and we can count on the animals that migrate through our areas. All those forms are kind of his checklist. They're his signs that, okay, it really is time to go get your winter coat on. I know you don't want to, right? So we need those things too to run our day in, but we need to do it in his example. He gives us, many hours of light, many years in a lifetime, right? Too many
Hmm.
daisies to count. So there's lots of
Hmm.
opportunity within that structure. And that's all we're trying to get people to see. You
That's so
cannot fail,
good.
you'll fail your child at math if they just know, mom and dad like math enough to make me do sometimes. And then there's times where we just enjoy it together, right?
Hmm.
That's what it's almost like always looking to see what is it I want them to do with my grandbabies because we're going to fail at this. We've never done this before. You've never had
Hmm.
those kids this week during those topics, right? We've talked about that many, many times. And you want them to be confident and competent when they have their children and they're saying, I have never had a child like this before and I don't know what to do. You need to say, well, there's room.
Yes, that's so good.
Mhm.
Thank you. That's so because we do tend to want to, even within ourselves, we are polarizing, right? We're like, I want it to be all this or all that. So we hear somebody say, "Hey, the checklist's not the most important thing," and then we chuck the checklist. Or then we hear somebody say, "Hey, if you don't have a checklist, you might not be doing this so great." And then we all in on the checklist. But this tension that we have, where God is not saying there's 14 daisies in the field every year. There are probably going to be daisies in the field every year. And actually, sometimes the daisies might fail because of the frost. But guess what? Over the course of time, this is still the form that we use. That is so, so helpful.
Yeah, because what we don't want our children to do is think school is a prison, and as a society, I'm getting on my soapbox, we're headed more and more to prison-like behavior. We want somebody
Yes.
else to feed us. We want someone else to provide the roads. We want somebody else to provide the education and the help there. We want someone else to provide the clothes. And that's just not the freedom that the Lord has given us. And so the more we act like there's some rigid structure that we're going to fail against and be punished by, well, we're then in a penal system. Well,
Mm,
he's trying to
so
help us be
good.
free.
That's so good.
Right, and sin's our penalty, the consequences of it. Not
Yes.
not the not the inability to quite grasp calculus at 15.
That's so good. Thank you. That's so good.
All
Okay,
right.
more questions.
So our next question, I think this is really, really fun. This question is from booklet 19 of monomials on page 13. We're looking at vectors. And the question here was, what is the vector from the origin? And is there a correct answer? So I thought this would be a great problem to sort of work through. And because it's telling you to go outside and do this. So if you look at this, the first thing it does is it tells you to measure your stride. So we might want to talk with our students. What does that mean? Does anybody know what your stride is?
Is it the distance between your 2 feet when you're
So
walking?
it's if you take 2 steps, that's your stride. So you have one step, right? If I step and then I take another one, that is my stride. So the first thing I need to do is I need to go out and I need to measure my stride. Then it says, okay, you can change directions, but you're going to pick a direction and let's call it north, and you're going to walk 35 feet. Then you're going to turn 90 degrees to the right and you're going to walk 30 meters. Then you're going to turn 90 degrees to the right and walk 42 meters. Then you're going to turn 90 degrees to the right and you're going to walk 85 feet. Then it says, okay, so your end point is where you started. So we would have a flag or something there. And then the question is what is our vector back to where we started? So as we look at this, what is the first thing that jumps to somebody's mind? If you look at this diagram here, we have feet, meters, yards, and feet. What might be the first thing I would want to do?
We converted them all to feet.
Perfect. Yes, we would convert all of these to feet. And so if we do that, make sure I've got my pen on here. Yep, I've got my 30 meters times 1.09 yards over 1 meter times 3 feet per yard. And I get 98 point, is that right? 98.1 feet. Okay. And then my 42 yards, I can use my, 3 feet per yard. And I get 126 feet. And then everything else is in feet. If I'm doing this out in the wild, it's going to be different to if I do it here on a piece of paper. So we're going to walk through this on a piece of paper, but I want you to understand that if I'm doing this out in the wild, right, it's going to have a different feeling because we're not going to be perfectly accurate. So the first thing that I would do as I look at this is I would go ahead and I'm going to redraw this with my new units because I'm going to discover that the drawing that is there doesn't necessarily fit what I'm going to do if I'm actually doing this. So I start at some point and I go 35 feet. Then I have 98 feet. That's going to be almost 3 times as far. So 98.1 feet. And then 126 feet. And then 85 feet. And my question is, I'm going to change my color here so we can see what we're doing. How do I get back to where I started? Now, when we say calculate the vector from the origin, what we're meaning is to remind our students that our vectors are defined as though from the origin. So maybe if we had said calculate the vector as though from the origin, I think that might have helped. So there's 2 ways that we can do this. The first way that we could do this is by saying, well, if I'm in 2 dimensions, how many coordinates does my vector have?
2.
2. I may have a horizontal and a vertical, right? So how much farther would I need to walk in order to get back to my starting point? So I went 98.1 feet this way. Now I've gone 85 feet this way. So I need to go a little bit farther by how much?
About 13 feet.
About 13 feet, right? So 13.1 specifically.
Sure.
Which obviously that would not be out in the real world, we're not going to have 0.1. But since we're doing it here, we might as well. All right, so there's our 0.1. My pen turned off. Point one. Now, then if I was to go north again, notice that if I was to look at what I did, I went 35 feet north, then I went 126 feet south. So now I need to go north again. And how far north would I have to go?
89. Oh, no, 91.
91. So right there, and that's something we could actually estimate by walking around outside, right? Because you could say, okay, keep walking until you're lined up this way and count your steps. Now turn and walk towards it and count your steps. And we're going to see that my vector, if I call this U, I would have gone negative 13.1 or 13.1 west, however you want to think about that, and then 91. And I would say you could stop right there. All right, and there's your vector. If you wanted to go that extra mile and do this another way, the other way that we could do this is, and I think this is maybe where you went, because you were like, well, how far am I? I want to know how far I have to walk. Well, if I was to calculate the distance, I can use the Pythagorean theorem because I have a right triangle. And so I would have my 13.1 squared and my 91 squared. And if I simplify that, I end up with about 91.9 feet. Now, if I'm doing a two-dimensional, really, right, my vector here in polar coordinates, I'm going to need a radius, which is my 91.9 feet. And I'm also going to need an angle. Right. So this now here, what I would do is I would say, well, I can figure out what this angle here is. And that angle would be my inverse tangent of 91 over 13.1. And I'm going to be able to calculate that, but then I'm going to subtract that from 180 in order to find out what this angle is, because I'm going to define it from there. And if I do that, I'm going to put here 180 minus this. If I do that, I'm going to find out that it's about 98.2 degrees. And so I can also write my vector as 91.9 feet and 98.2 degrees. Now, could I do that? I could, right? Because I could say, okay, estimate you're facing this way. Now rotate, right? Turn your body until you see the flag where you started. And I want you to kind of estimate that angle. And now I want you to walk and count. So I could do this both ways out in the real world. Sorry, my slide changed here. I don't know what I did. So I could do this both ways out in the real world. I think that my green way there, just going this way and turning 90 degrees is probably the easiest. But those are the two different ways that I could look at that. Does that help?
It does. Yes. Thank you so much.
I think it's a really fun problem, right? It's a really fun exercise to do with your students.
Because we had so much fun doing that, because we were outside, we had to go through the garden, and then we had a little hill, so we know how accurate. So we just went, when we got to the end, we actually then just did the angle, did the vector just back to the origin. And we got about 84 feet is what we did. And then we kind of went back in the northwest direction, and we figured, okay, that would be, right? Would that be an accurate vector too?
Yeah.
Okay.
And then for parents with the younger kids, just take a tape measure and just measure that distance, measure the gap, and that's good enough until they're older.
And one of the things that I would say I might do, I haven't done this problem with my family, but I could just take it in steps. And the first thing I would do is say, is this drawing correct? Because let's do 30 meters compared to 85 feet, and then you figure out that 30 meters is 90 something feet. You're like, oh, so that line should actually, that is, I think, a really great conversation, that you can just have about conversions, and that could be
Right, and it
fun.
doesn't change the math, except that your right triangle is, I don't even know how, I don't have the vocab to say that, but it's like you're going past the right
Inverted.
angle and coming back instead of,
Well, I
yeah.
can tell you what happened is we kept the image from an earlier lesson and changed the numbers and didn't think to redraw it. So
Yeah.
I actually will go redraw it so I don't confuse anybody.
But wasn't
But
one
it
of
is
those things you did in one of the earlier pages about sketching?
But we
Mm-hmm.
can say not drawn to scale is another
Mhm.
thing.
yeah.
Mm-hmm. That's a good
I
conversation.
mean, that's a great skill. That alone is challenging your students to say, okay, assume this is not drawn to scale. Now, I want you to take these measurements and these numbers, and I want you to draw it to scale, right? So take a piece of graph paper and draw this to scale, because that alone is a skill in being able to do that, right? What scale would I need to use, right? So we happen to be a big Lego family, and so we're always talking about what scale, what would this be if it was minifig scale, right? How huge things would be if they were minifig scale, right? Like, so my son was pointing out that the container ships that carry all the stuff from China, if it was minifig scale, it would still be wider than than the room I'm in, which is a pretty wide room. It's like, Mom, you couldn't fit it in here at minifig scale. So just those conversations with your students about scale and drawing those correctly, that's a great skill to practice on an exercise like this. All right. And the last question we have that was sent in, certainly happy to continue to answer questions after this, but this one was also sent in. And this was a family who's talking about the fact that there's sort of a hidden piece of knowledge that you need for some of these. When we're talking about reflecting across the x-axis and the y-axis, it's something that I think we can visually see and understand somewhat straightforward in a somewhat straightforward way. So if I say to reflect across the x-axis, we can all go, this is my x-axis. And so a reflection is going to be this mirror image across the x-axis, and I can see that visually. What happens is when we try to do that algebraically and we start to put numbers in, we see the x-axis, and we need to come up here and say, well, I don't have the x-axis listed. So the missing piece of information here is to go, well, what is the equation for the x-axis, right? As I look at this, and if I think about my lines, right, this is my y equals mx plus b. What is the slope of the x-axis? 0. What is the y-intercept of the x-axis? Where does it cross the y? 0. And so notice that when I talk about my x-axis, wrong, because the variable x isn't in there anywhere. My equation is actually y equals 0. So my gut, right, here's a case where my gut says I want it to be x equals something. I need to use that x piece there because that's my x-axis. What it really is y equals 0. And so when I'm talking about reflecting across the x-axis, I actually need to use y equals 0, which means that c equals 0. That means my point xy is going to go to the point x negative y plus 2 times 0, or x negative y. Right. So we can see that algebraically, but I would encourage you now to go back and say, let's take a look at what we're doing and see if that makes sense. So I come back over here and I look at this point, which happens to be 1, 0. I'm sorry, 0, 1. I can do this. 0, 1, right? My x is 0, my y is 1. When I reflect it, right? If I was to fold this in half, my x isn't going to change, right? If I was to take my graph and fold it along my x-axis, right? I'm not changing where it is left to right. So my x doesn't change. Whatever this looks like, it has to be 0. Again, my reflection, right? If I was to look at this as a mirror and I folded it over, however far I was going up, I now have to be that far going down. So the distance has to be the same. So it was 1 there, it has to be 1 here. Here it was in the positive direction. Here it's in the negative direction. And so my y is going to be my opposite value. I can do that with b, right? So here my x was -2. My y is -1. When I fold that in half to reflect, I can see my x didn't change at all, right? It's still -2, but now I have the opposite y, right? Because I've basically gone back to that x-axis, and now I'm going that far again. That's the 2c part, right? I've got to go back to where I was and then go again. And so that's where I see this and I go, okay, well, it's the opposite, because as far as I went, I'm going that far again, over the 0. So we can look at this in and think about what does reflection look like and look at it in the image. But I also wanted to point out that when we think about this algebraically, there's that piece that if we're in our first year, that piece may not be obvious, that our x-axis is the same as the line y = 0. So for that family that asked this question, I'm sure they're not alone, that is probably the missing piece for those reflections, right? Is understanding that the x-axis is y = 0 and my y-axis is going to be where x = 0. And again, we can see, looking at those rules for transformation, if I'm flipping it this way, my y value doesn't change, but my x does, right? I'm changing my x value when I reflect across the y-axis. My y value changes when I'm reflecting across the x-axis. Any questions on this one?
I just want to suggest you look down at the decimal fraction or rational version if this is really causing you to stumble, because that's where we ask the students to identify that y = 0 is the x-axis and x = 0 is the y-axis. We help them with the vocabulary and the counting on the grid. This is tough. So if you jump right in at this level, this is tough.
Okay, so my question is, can you help us know, like, if I'm assuming this parent, it doesn't know that, or the y = 0 doesn't come to the mind of the parent readily. And so, like you said, they would have to look down. They may not even know where to look down to without all of that. But like, can you give us some questions that we might ask our students to help them get to that answer, to that realization? Like questions that we might think of to ask. I mean, because this question is basically saying, I can't find the answer in the charts.
So I think I would look and I'd say, okay, what are your options in the charts? Okay, so let's look and see, what are your options in the charts? X = C, y = C, origin, y = X, y = -X. Are there any of those that you can discount? Which ones are not the x-axis? Right?
Well, even then, to do that at first, they need to throw some numbers in. I always have to throw numbers in for my x for me to be sure that I'm doing things right. So I might pick a 1, the number 1. Like I love working with 1, -1, and 0, and just plugging and chugging and trying. And that usually shows me where at least I'm wrong and where to head towards.
So if you're not remembering what the graph for y equals x and y equals negative x looks like, then Lee is giving you a great strategy, right? To see, does that work? And so I might either quickly from my memoria or from that strategy go, well, I know it's not y equals x and I know it's not y equals negative x. And the origin is a single point. So can the single point be the same as the x-axis? No. So I could probably cross that off. So now I'm left with this x equals c and y equals c. And so I can either do what Lee just said and start making a chart of points and seeing which ones work, right? Or I could start going, okay, wait a minute. If x is c and y equals c, what kinds of lines are those, right? Start thinking, let's go back and think about what kind of line is x equals c. If x is always 5, what kind of line does that mean? No matter what the y is, x is always 5, right? And just think through that with your student, right? It's always 5. It's never left or right. It's always 5. It's a vertical line. Okay, well, what if y is 1? Right? It's a horizontal line, right? Because it's not going up or down. It's a horizontal line. So just stopping and thinking, what does this mean? And so now I might go, well, the x-axis is a horizontal line, so it can't be x equals. So now I might get to the point where it's y equals c, but how is that the same? And that's when I might say to my student, okay, well, what would y equals 5 be? What would y equals 4 be? What would y equals 2 be? And see if I can help them to get to where they go, oh, wait, well, if y equals 0, that's the same line as the x-axis. Right. So I would probably start with that process of elimination, figure out which one it could be, and then see if we can find how do I make this be what I need it to be for this.
Something you could do practically or concretely for what Kirsty just said is get a toothpick and put it on this grid and lay the toothpick on each of the lines of the grid and ask the child to identify what's y's value everywhere on this toothpick or what's x value everywhere on this toothpick, and then move it to the 3 or 4 different lines and the axes. I think that would help them pretty quickly, because when Kirsty, when you were describing it, I was thinking, okay, it took me the longest time to understand that y equaled 5. When someone would say, well, it equals 5, because we're so used to it, I know it's everywhere. Well, it's everywhere didn't occur to me at first. So I didn't even know that fundamental piece. So this is, again, why we're always talking about, slowing down, reading what's in front of you, figuring out ways to draw it out, try it from different angles. I need to go. I have another.
Well, thanks for joining us, Lee. All right. Are there any other questions that anybody has brought today that they'd like to talk about? Well, we had some great conversation, and I know that I'm leaving encouraged. I hope everybody else is. I'm going to throw this out there, and because I was scrolling on Facebook and I saw some math Valentines, and I thought that it would be fun to challenge our students to create their own math Valentines. So instead of us on the Facebook page being like, here are some math Valentines, I want your students to create some math Valentines to send to us. Right. And so here's my attempt. So I am not an artist, right? And nor am I probably very funny. But I was thinking about, I could send this. Right? Together we're just right. Okay. Right. So that's my, right, here's my effort. Together we're just right. Because there's my right angle when we're holding hands, right? So take that for what it's worth. And I'm going to ask Babs to put that challenge out on Facebook, but I wanted to invite all of you to have your students see if they could come up with some fun math Valentines. Send them to us on the Facebook page, or you can email them to us, and we might pick a couple of our favorites to share next week, which will be right just a couple of days before Valentine's Day. So you've all got a week to come up with your very best math Valentines.
Thank you guys. See you next time.
Hey, Dr. Gilpin, I just want to say
Yes.
a friend of mine, a good friend of mine, told me that you are a good friend of his. His name is
Oh,
Shane Scott.
yes. You know Shane. That's awesome.
I've known Shane for 25 years.
Wow. That is really
Yeah.
cool. Yeah,
Yep.
he
I
does
thought I
some
would tell
good
him.
work. We've known Shane about that long because we were in life group together with him. Let's see, I got married, I guess almost 20 years. So we got married in 2004. So we started going to Calvary um probably in early 2005, and that's when I met him. And you can tell him he led our life group one week talking about communion, and like I remember what he said to this day. Like
Oh,
every
that's
time
so cool.
I take communion, I think about him and what he gave us that day in life group. So you please pass that along, that that
I
was
absolutely
that was
will.
that
That's so
impactful.
cool.
Yeah.
That is so
Oh, that's
cool.
awesome.
I mentioned you to him. Well, we were talking about math stuff, and he's like, you're on the call, you know?" And he's like, "We're good friends." It was like we had a great conversation, and at some point, I was like, "I'll mention it to her." At some point, I didn't know when I would ever, but that's
Oh, I'm
pretty
so
cool.
glad you did. That is
Yeah,
really
we
cool.
worked together. I was still single. He was married, just barely married, when we worked together back in Chicago from 2000 to about 2004 or five or something like that. Yeah, so
Oh,
that
that
was
is
fun.
great. Yeah. Oh, wow. Small world.
Yes, it really is. He's been in Jerusalem and everywhere since then, and now and I didn't realize you were in Florida, so that's pretty cool. Anyway,
Very cool.
yeah.
All
So
right. Well,
y'all have a
thanks.
great day.
You
Yep.
too.
Bye.